Welcome back, everybody, to the deep dive. This time, we're going deep on something I know you're all interested in: machine learning for oil production.
Oh, yeah, this is a hot topic.
We're looking at a paper from the SPE Western Regional Meeting just last year.
Okay.
It's called, get this, Machine Learning Models to Predict Production Rate of Sucker Rod Pump Wells.
Catchy.
Right.
hmm
So the big problem this paper is trying to solve is, how do we figure out how much oil a well can produce, especially in these older fields with a ton of wells?
Yeah, and especially without having to use really expensive equipment.
Exactly. So that's where this kind of cool blend of old and new tech comes in.
Oh, yeah?
We're talking about machine learning, but applied to something that's been around forever, the sucker rod pump.
Exactly. Think of it like pretty much, yeah.
Okay, so this paper looks at 9 different machine learning models to see which ones can best predict how much oil these pumps are bringing up. And they use a massive data set from Egypt, almost 600 wells tracked over 3 years.
Yeah, it's a lot of data.
Yeah.
And it's not just simple stuff either.
Oh, right. What else did they look at?
Well, they factored in things like the pressure at the wellhead, the kind of pump being used, the depth of well, even the properties of the oil itself. Like, is it thick or thin?
Wow, okay. They really went all in. But before they could even start training these models, they had to get all that data cleaned up and organized.
Oh, yeah.
Like making sure everything's using the same units and there aren't any mistakes in the data.
Right. So that's the data preprocessing and normalization part that's super important.
Why is that so crucial?
Think of it like this. You're baking a cake, right?
Okay, yeah.
You need to make sure your measurements are accurate, otherwise your cake is going to be a disaster.
That's a good analogy.
Same with these machine learning models.
Sure. So bad data equals bad predictions.
Exactly.
Okay, so data's prepped. Let's talk results.
Right.
Which models were the stars of the show?
Okay, so there were 5 that really stood out. Gradient boosting, AdaBoost, random forest, linear regression, and stochastic gradient descent.
Wow, okay. That's a mouthful.
Yeah, I know, right? But the key thing is, these models had the lowest errors. So their predictions were super close to the actual oil production. Like, we're talking accuracy rates in the high 90s.
Really? That's impressive. But how do they even measure accuracy in this case?
It's kind of like, imagine you're trying to guess how many marbles are in a jar.
Okay.
The closer you are to the actual number, the more accurate you are, right? Well, these models, they were pretty much spot on.
So they nailed it. But how do we know these results weren't just a fluke? Like maybe they just got lucky with the data.
Good question. So they didn't just run the tests once. They used something called K-fold cross-validation. Basically, they shuffled the data a bunch of times and ran the models again and again, just to make sure the results weren't a one-time thing.
Okay, so it's like double-checking your math problem just to be sure you didn't make a mistake.
Exactly. And then on top of that, they also did repeated random sampling, like really mixing up the data to see if the results held up.
Okay, so these models seem pretty reliable, but did they actually test them out on a real well, like in the field?
They did. They picked a well, called it Well X, and they used the AdaBoost model to predict its production rate. And this is where it gets exciting.
Okay, I'm all ears.
The model predicted the well would produce 297 barrels of oil per day.
All right, drum roll, please. What was the actual production?
290 barrels per day.
Whoa. So they were only off by 7 barrels.
Exactly.
That's incredible.
Right. I mean, that's amazing accuracy.
So this is more than just theory. These models could actually be used to manage oil production.
Totally. It could change everything.
Okay, I have to ask.
Yeah.
What does STBD mean? I keep seeing it in paper.
Oh, right. SCBD means stock tank barrels per day.
Uh,
It's just how they measure oil production.
okay. So the model predicted 297 STBD. That's amazing. Imagine being able to just like adjust pump settings based on these predictions.
Right. Talk about efficiency.
Yeah. Okay, but before we get too far ahead of ourselves,
Yeah.
let's talk about why knowing the production rate of a sucker rod pump is so important in the first place.
Good point. It might seem kind of basic.
Yeah, I mean, it's just how much oil you're getting, right?
Right, but it's actually way more than that.
Yeah.
It's like, how doctors always check your pulse?
Yeah, to make sure you're alive.
Right. It's like a vital sign. It tells them how your heart's doing.
Okay,
Well, the production rate is like the pulse of an oil well.
interesting.
It tells us how healthy the well is, how much oil it can actually produce.
And like with a heartbeat, you want to see a steady rate.
Exactly. A steady rate means things are working as they should.
Okay, but what if it's not steady?
That's when we got to investigate.
Like a doctor would order more tests.
Yeah, exactly. If the production rate drops suddenly, it can mean a whole bunch of things. Maybe there's a leak somewhere or a blockage in the pipes, or maybe even something wrong with the oil reservoir itself.
So it's a clue that something might be wrong.
Right. And knowing the production rate helps us catch those problems early on before they become major headaches.
So we can fix them before they get worse.
Exactly.
Right.
And it's not just about troubleshooting problems, it's also about getting the most out of the well.
Okay, yeah, I was wondering about that. How do we use this information to actually produce more oil?
Think of it like fine-tuning a recipe.
Okay.
Let's say you're baking a cake. You might adjust the oven temperature or the baking time, depending on how the cake is rising.
Right, to get that perfect, fluffy cake.
Exactly. With oil production, we can adjust the pump speed or the stroke length based on what the production rate is telling us.
So we're tweaking things to maximize oil production.
Right. And it's not just about getting the most oil out. It's about doing it in a way that's both cost-effective and good for the environment.
Oh, that makes sense. So if we can use less energy to produce the same amount of oil, that's a win-win.
Exactly. It's about finding that sweet spot where
Yeah.
we're maximizing production without wasting energy or harming the environment.
Okay, that makes sense. But what about the financial side of things? I imagine oil companies need to know how much oil they're going to produce to plan their budgets, right?
You got it. Production rate is crucial for financial forecasting and planning.
I mean, it tells them how much money they can expect to make, right?
Right. They need that information to make smart decisions about investments, hiring, and future projects.
It's like planning your household budget. You got to know how much is coming in.
Exactly. And these machine learning models, they give companies much more accurate predictions.
So they can plan more effectively. Okay, so we know these models need data to make those predictions. Like you said, they look at well depth, pump size, all that stuff. But where does all that data come from?
That's the best part. It's all data that's already being collected.
Really? So they don't need any fancy new equipment?
Nope. It's all stuff operators are already tracking. These like wellhead pressure, pump settings, the properties of the oil. It's already there.
So they're using existing data to make these predictions.
Exactly. It's about using the data we already have in smarter ways.
That's awesome. So we've got this super important production rate, and we've got these machine learning models that can predict it really accurately. What kind of impact could this have on the oil and gas industry as a whole?
Well, think about it. If we can accurately predict production, we can start optimizing everything.
Like making things more efficient.
Exactly. Imagine a world where pump settings are automatically adjusted in real time based on these predictions.
Wow. Like a self-driving car, but for oil production.
Yeah, kind of. It's about letting the machines do the heavy lifting.
So we're talking about making oil production more automated.
Right. More efficient, less wasteful, potentially even more environmentally friendly.
Wow. That's pretty amazing. But are there any downsides to all this? It can't all be good, right?
Of course, there are challenges.
Like what?
Well, one of the biggest is data quality. Remember what we talked about earlier?
Yeah, about how bad data leads to bad predictions.
Right. So we need to make sure the data going into these models is accurate and complete. Otherwise, the predictions won't be reliable.
So garbage in, garbage out.
Exactly. And then there's the issue of interpretability.
What do you mean by that?
Well, these machine learning models can be pretty complex.
Yeah, I'll say.
It's not always easy to understand how they're making their predictions.
So even though they might be super accurate, we don't really know why.
Right. And that can be a problem, especially in an industry like oil and gas, where safety is paramount.
I see. We need to be able to trust the predictions.
Exactly. And to trust them, we need to understand them. So there's still work to be done on making these models more transparent.
Okay, that makes sense. But what about the people who work in the oil and gas industry? How will this technology impact them? Are robots going to take over all the jobs?
That's a big question. I think it's important to remember that machine learning is a tool.
Okay.
It's not here to replace humans. It's here to help us.
So it's about humans and machines working together.
Exactly. These models can automate certain tasks, but they still need human oversight.
So people will still be needed.
Absolutely. In fact, this technology could even create new jobs.
How so?
Well, think about it. Who's going to develop these models? Who's going to implement them? Who's going to maintain them? We're going to need data scientists, engineers, technicians.
Right. So new jobs, new skills.
Exactly. It's all about adapting to new technologies.
This has been a fascinating look into the world of sucker rod pumps and machine learning.
It has.
We've learned so much. But what's really interesting is that this technology has applications way beyond oil and gas.
Oh, yeah, absolutely. The possibilities are endless.
That's what we'll be talking about in the final part of our deep dive. We'll be looking at how these machine learning models can revolutionize other industries, from water management to transportation to healthcare.
Welcome back to the deep dive. We've been exploring how machine learning is transforming the oil and gas industry.
And it's not just oil and gas.
Right. What's so fascinating is how these same principles can be applied to all sorts of other fields.
It's like we found this new tool that can help us understand all these complex systems.
And not just understand them, but predict how they'll behave and actually optimize them.
Exactly. Any system that generates data, and these days that's pretty much everything, can potentially benefit from machine learning.
So it's bigger than just oil wells. It's about using data to make everything, like cities, power grids, even healthcare, smarter and more efficient.
Absolutely. Let's take water management, for example. Okay, yeah, a city's water system, that's pretty complex.
It is. You've got this huge network of pipes and pumps all working together to deliver water to homes and businesses.
It's like the circulatory system of a city, keeping everything running smoothly.
Exactly. Now imagine we have sensors all over this network,
Okay.
collecting data on water pressure, flow rates, even water quality.
Okay, and what do we do with all that data?
We feed it into a machine learning model, similar to the ones used for predicting oil production.
And what kind of insights could we get?
Well, for one, we could predict leaks
Oh, wow.
before they even happen.
So we could prevent those big water main breaks that always seem to happen at the worst possible time.
Exactly. No more digging up streets in rush hour. And we can also use these models to make sure water is being delivered efficiently.
So we wouldn't waste as much water.
Right. Especially important during droughts.
Okay, so smarter, more efficient water management. What else?
Let's think about transportation. Imagine applying these principles to traffic flow.
We've already got sensors collecting data on traffic, right? Like speed cameras and those things that count cars.
Right. And with machine learning, we could use that data to create a real-time traffic management system,
So no more rush hour gridlock.
potentially. It would optimize traffic flow, minimize travel times. Of course, there are challenges.
Yeah, I can imagine. Traffic is pretty unpredictable.
It is, but the potential benefits are huge. Less stress, less wasted time, less pollution.
Okay, that makes sense. Now I'm thinking even bigger. What about healthcare?
Healthcare is already being transformed by machine learning.
Right. I've got this smartwatch that tracks my heart rate, my sleep, everything.
Exactly. And we've got electronic health records, imaging technology. It's a ton of data.
And with machine learning, we can make sense of it all.
Exactly. We can detect diseases earlier, personalize treatments, even predict health outcomes.
Wow, that's amazing. So what's the big takeaway here? What do we want our listeners to remember?
I think the biggest takeaway is this. We're living in a world overflowing with data. And with machine learning, we can unlock the potential of that data to solve problems and make life better.
It's not just about oil wells or water systems or even traffic.
It's about using data to make a better future.
This has been a truly eye-opening deep dive.
It has.
We've explored how machine learning is revolutionizing the oil and gas industry, and we've seen how those same principles can be applied to countless other fields. The possibilities are truly endless.
Absolutely.
A huge thank you to our expert for joining us on this incredible journey.
My pleasure.
And to our listeners, keep those brains buzzing and stay curious. We'll see you next time on The Deep Dive.